re tlo e etsa.
Yeah,
Ya, re tlo e etsa le yona. Ke na le yona sa.
all right,
Ke rometse question paper teng ya power transfer.
all right.
Re tlo e etsa.
Oh,
Yeah. Okay. Um, so we'll start with question 3, the one of use superposition theorem. In figure 3, determine
that one will remain like
the one that we're now sentencing on.
oh, all right.
Rhythm guy on.
Sure, we'll try. Yeah, I can try my
Rike throw ibo. Yeah, this one.
yes.
So you know what we're going to do? We will apply, we will start first applying superposition. After that, we prove our answer using Norton and Thevenin.
All right.
Yeah. Yeah. So our RL is 12 ohm. They say, question says, use the superposition theorem in figure 3 to determine the current flowing through a RL, which is 12 ohm. Ne? Yeah.
Yes,
Oh, good.
yeah,
Yeah. So
yeah,
okay. So we have current source, voltage source. So when we again superposition, we use one source at a time. So we can't use both sources at the same time. So we use one source at a time. So
yeah,
what we're going to do, if you want to eliminate a current source, you open circuit. If you want to eliminate a voltage source, you do a short circuit. So let's start with the voltage source. That means I'm going to eliminate my current source. So I'll redraw the circuit for eliminating of the current source. So normal superposition is the application of circuit analysis.
yeah, all right.
Yes. Six, 8, 20, 12. 4, 9. So when you eliminate current source, you open circuit. So open circuiting of these two currents, I will just remove them. Then the circuit will look like this. Therefore, remember, I'm applying a superposition. So always using a one source, find the current through your RL. Always using what the superposition theorem, we are going to get the current through 12 ohm using 9 ohm and 3 amperes and 2 amperes. Therefore, at the end, we are going to add or subtract them. So now,
All
since
right.
I'm looking for the current for RL and only one source, what I'm going to apply what circuit analysis to get the current through 12 ohm. So these two, I'll start always when you want to calculate the current of a resistor, you always start away from the source. To approach the circuit or to get the total resistance, we always start away from the source. That's a law when you're applying circuit analysis. We will always start away from the source. So away from the source, I'll start from 6 ohm. 6 ohm and 8 ohm, they're connected in parallel. So I'm going to have RP1. I'm going to have RP1, which is equals to 8 times 6
Times 8.
divided by 8 plus 6. Then 8 times 6 divided by 8 plus 6 is 3.42.
3 point. Yeah.
3.429. I'll round off my values to 3 decimal places. So after doing that, then this combination is going to be parallel with the 12 ohm. Then I will have R S1 is equals to 3.429 plus 12 is equals to 15, 15.429. Therefore, that will be parallel with 20. Then RP2 is equals to 15.429 multiplied by 20 divided by 15.429 plus 20. So that is RP2. So it's 15.429 times 20 divided by 15.429 plus 20 gives me uh, is 8.70 or is 8.71. Let me erase it. 8.710 ohm. So that RP2 is gonna be placed on 320 on the 20 ohm. Then I'll have how many? I'll be left with two resistors, which is RP2 and then 4 ohm. So they're in series. So remember, I'm looking for the current through RL. I don't need to get the total I don't need to get the total resistance or total current. I just want the current through RL. So since I know the RP2 is going to be placed on 20, and I'll be left with the 4 and 20 in series and then the 9 volts. So I'll get the current through 20 ohm. Normally the current through 20 ohm it will act as a total current. I'll be left with something like this. Let me throw it here. After finding the RP2, I'll be left with something like this. 8.7.
I don't know one other screen anymore, like the part mode drawer.
Where fast?
Eh,
Mara mo ujuma
how
awal.
am I supposed to scroll?
Iri ngos koron.
Mo godimo ke a go.
How scroll area?
I can't, I can't scroll.
Can't scroll. Irke want something. Can't scroll. Mm. Wabon? I want to know.
Make it on. No.
Irke want. O bona fela kwa godimo.
Ke bona fela mo godimo. Oh, shit, sorry. Really not for no way but I saw it just now.
Oh, Shagwell no.
Yeah.
Okay. So since now, okay. So after calculating RP2, we will be left with this circuit. We'll be left with this circuit. 4 ohm and 8.70 connected in series, and then 9 volts is supply. So remember, we're looking for the current through RA, which is the 12 ohm. So from here, I want the current through 8.70 because 8.70, it has a 12 ohm. It has my RA. It has the combination of my RA. That's why I'm looking for the current
Right.
through it. So I'm going to use a normal Ohm's law. Then I will say IRP2 is equals to 9 divided by 4 plus 8.701. So my current is going to be 9 divided by 4 plus 8.710 is equals to 0. It gives me 0.708. So now I've got the current through RP2, and I'm looking for the current through 12 ohm. So what is the combination of RP2? What formed RP2? RP2 is formed by RP1 and my RL. And how are they connected? They are connected in series. So that means since they're connected in series, and then the RP2 acts as my total resistance. Ne? The RP2 act as my total resistance of what formed it. So what formed RP2? What formed RP2 is 15 and 20, and the 15 is from RS1. So normally my RP2 is formed by 20 and the 15, which is RS1. So now, since RP2 is formed by 20 ohm and my RS1, now I'll have to get what? The current through RS1, because RS1 is the one that have my resistor, my RN. So what I'm going to do using this current, I'm going to use a current divider rule to get what? The current through RS1. Why RS1? Because RS1 is the one that have my RL. So I'm going to apply current divider rule. So I RS1 is equals to 0.708 multiplied by 20 divided by 20 plus 15.429. Why I'm doing this? This is alternative way. I can do it manually by starting with the RP2 and then the 20 ohm, and then using the voltage divider from the. But then I'm just applying this method of current divider rule because it's alternative way of getting the current through my RS1. So normally, is it important to label your resistors because they tells you how are they connected. Since I wrote RS1, it tells me what is series resistance 1. So RP1 is it means a parallel resistance 1. So series resistance 1, it tells me the resistors that I have, they connected in series. So if I get the current of the total RS1, that means I got the current of the combination of that resistor that forms
Yeah.
RS1. So since now, if now I get the current through RS1, that means I have current through what? Through the RP1 and my 12 ohm, which is the load resistance. Why? Because they're in series. So that means if I get, remember, the RS1 acts as a total resistance of what? Of the RP1, which is 3.429, and the 12 ohm. So the RS1 is their total resistance. So that means if I get the total current or the current through it, that means I have what? The current of these two because they are in series. They share same current. So finding the current through RS1 is the same as finding the current through 0.429 and 12 ohm. Why? Because they are connected in series. So
Right.
I'm getting uh, 0.708 times 20 divided by 20 plus 15.429 is equals to 0.4. Normally 0.4 since I'm rounding to 3 decimal places. So it's gonna be 0.44 amperes. Or you can write 0.399. But if you're rounding three decimal places, it's going to give you 0.4. So therefore, IRL 1. Remember, I will have to get how many currents? Three currents because I have three source. It's superposition. So IRL1 is equals to 0. IRL1 is equals to 0, 0.4 amperes. Why? Because their total resistance of IRL is IRS1, and RS1, if I have the current, that means I have the current of what formed it. So that's the first current for my IRL1 using the voltage source. Load resistance 1 current using the voltage source, which is 9 volts. The current I got 0.400 amperes. Understand?
Yes, I understand.
So we can move to the next source.
Second
Um,
part.
mm, I will add another page uh, using current source. So let me write for something here and then say mm, for VS. This was for VS, and then now we are going for mm,
The amps.
for IS1. So IS1 means current source 1. Since we have two current sources. Remember, for voltage source, to eliminate the voltage source, we're going to do a short circuit. So we're going to do a short circuit. To eliminate the voltage source, we will do a short circuit. I'll have my current source there. And the other current source is still is gonna be eliminated by open circuit. Oh, sorry. Uh, I have this before I have that. I must have.
Aqui vou no draw, guys.
Okay,
Aqui vou no draw.
go to the next page.
Oh, all right. I see.
You can see.
Yes.
Yeah, we're on the next page. The thing of Zoom is more advanced than centimes.
Yeah, okay. I didn't know it was really.
Yeah. The resistance here is 6 ohm, ne?
So that one is
It's what?
8.
It's 8. And here is still my 12 ohm, which is
Wow.
my load. And then here is 20, ne?
Yes.
And then current, and then here is what? We don't have resistance here.
4.
We have,
It's
it's
4.
4. Yeah, it's 4.
Yeah.
I guess that I can't see, but then now it's fine. Okay. So, yeah. The current is what? Is 3 amperes.
Yes, 3
We have 3 amperes current here. Okay, yeah. So now I'm applying what the current source one, and then I want to get the current through RL. So normally, if you're good in circuit analysis, then superposition is going to be simple because you're applying superposition. I mean circuit analysis. So if you're good in circuit analysis, that means superposition is going to be simple. So what is new is just a final answer of adding currents. We either subtract or we add. So now we want to get the current through 12 ohm, and then we have current source here. Is connected parallel. So we always start away from what? From the source. Always start away from the source. So we're still gonna have RP1 there, which is equals to 8 times 6 divided by 8 plus 6 is equals to 3.429, 3 point 0.429, and then still RS1. RS1 is 3.4, 3.429, 3.429, 3.429 plus 12 is equals to 50, 15.429 ohm. Therefore, RP2 is equals to 15.429 multiplied by 20 divided by 15.429 plus 20 is equals to
8.7.
8.71.
7. Yeah.
8 point, it's 8.71. Sorry, 8 point 8.71 can say 0. Oh, yes. So now we will be left with something like this. Allow me to put the resistor there. So now we'll be left with something like this. So is my RP2 over there, which is 8.710, and then 4 ohm. By eliminating the resistors and then trying to find the RP2, our circuit will look like this at the end. This is how our circuit is going to look like. You understand?
Yes, I understand.
So now remember, what are we looking for? We're looking for the current through 12 ohm. So that means normally we are interested in RS1. Why RS1? Because RS1 is the one that have 12 ohm. So what I'm
Yes.
going to do again, I'm going to apply current divider rule to find what? RP2. IRP2. IRP2. IRP2 is going to be 3 times 4 divided by 4 plus 8.710. So what is the current? 3 times 4 over divided by 4 plus 8.710.
0.944.
0.944 amperes. So 0.944 amperes, I'm interested in it, but then it's not my final current. So I'm gonna use it to get what? My final current. So what can I say? I can say IRL is equals to IRS1. Yes, I'm correct. Why? Because IRS1 is the total of IRL and the RP1, and then they are connected in series. So I'm correct. Why am I free meeting in 10 minutes? I'm having problems with my meetings. I will check. So 9.44 multiplied by
And
20 divided by
over
20 plus.
90.
Hey, my pen doesn't want to write anymore. Okay, it's fine. So 20 plus 15.429. Therefore, what's the current?
0.533 and
0.5
33.
0.533 amps. Yes, then that's the current for IRL using the uh, current source one, which is 3 amperes. Then let's go for the another one. Let's go for second page. But my meeting says it's gonna end. I don't know why my meeting's gonna end. Oh, okay, I still have time. I have 8 minutes. Okay, so for the second, uh, for the last current source, ne? For the last current source, I'm going to have 4 there, and then 20 there, 12 there, 8 there. So the current source now is what is how much?
2 amps.
And the resistance here is 6, 8, 12. And how much here? 20 and 4. So I have this. I have this. So I want to get the current through 12 ohm. And then we always start away from the source. So now away from the source, I'll start from the left side. I'll start from 4 ohm. Why? Because it's the one that is away from my source. So my RP1 again, RP1 is equal to 4 times 20 divided by 4 plus 20 is equals to 4 times 20 divided by 4 plus 20. 33. Therefore, my RS1 is equals to 12 plus 3, which is equals to 15. 15, yes. 15, 15.33. Therefore, my RP2 is equals to 15.333 multiplied by 8 divided by 8 plus 15.33 is what?
5.27. 5.257. Sorry.
5.257.
Yes.
5.257. Therefore, I'll have this at the end. 6 ohm, 2 amperes, and 5.257. 5.257. So I'll be left with this at the end. I'll be left with something like this. I'll be left with something like this. So it's still the same method, you can see.
Yeah, it was.
So it repeats itself. IRP2 is equals to 2 amperes times 6 divided by 6 plus 5.257 is equals to, is what?
1,066 M.
5.2 is what?
1,066.
Okay, 1,066 amperes. I'm not interested. I'm interested in what? In IRS, which is IRL is equals to IRS1 is equals to 1.066 times times 8 divided by 8 plus 15.33. So 1.066 times 8 plus 15.33. You're getting 0.365. Yeah. So that means it's IRL2. We have IRL. I mean, it's IRL3. Because remember, we have 3 sources, so we must have 3 currents. So it's IRL3. I'll go to the second page, page 2, then label this. So, and then IRL1. So the final current, yeah, it's fine. So the final current, ne? The final current is going to be the combination of your 3 resistors. We don't know if it's sum or is subtraction. So let's go to 4th page where we're going to write the final current. It says IRL, the final current is equals to. So I'll write down the currents. The first one was 0.4, ne?
Let me check.
Go to zero. Go when just go to the fourth page. I already I can see them now. Uh, the first one was it was 0.amperes. The second one
Yeah, plus
0 point
ya mathomo a kerbe e le 0 point
is 0.533. I'm gonna the third one. The third one is 0.365. Therefore, my Zoom is gonna shut down. I have a problem, but I'll fix it. So we'll start a new meeting. So let's just find the total current from this one. So what's the arrow going? Agree we're looking for the current through RL. Ne?
eh,
So this one is going up, ne?
eh,
And then where's this the resistance? Could mean that means the current of direction of this one is going to go in this direction for RL. Even this one is going to go in this direction. So what happens with this one? This one is going in that direction. So the sum of this minus that will give you what the final